Hello, this is Dr. Hanaa Assil, and this is about calculations involving moles. So the first question is, what is a mole? You should realize that mole is the relative atomic mass in grams or the molecular mass in grams. We know that the molecular mass is the total of the masses from the periodic table. So if we have sodium, sodium has an atomic mass or mass number of 23. So that means that if I have 23 grams of sodium, that is regarded as 1 mole. So it's a certain amount. If I have sodium chloride, you should realize that the molecular mass of sodium chloride, or the mass of 1 mole of sodium chloride, is the total of the mass numbers of sodium and chlorine. So that comes out to 58.5, and that means that if I have 58.5 grams of sodium chloride, that is regarded as 1 mole. If I have twice of that, then that is 2 moles, and so on. So the mole is the molecular mass in grams. Now we should also remember that 1 mole of any gas, and this is we're talking about gases, occupies a volume of 24 decimeter cubed at room temperature and pressure. So if I have 1 mole of any gas, its volume is 24 decimeter cubed at room temperature and pressure. Now, Avogadro's law says that equal volumes of gases contain the same number of particles. So we have something called the Avogadro constant. Avogadro's constant is 6.02 times 10 to the 23. And this says that 1 mole of a substance has this number of particles, or this number of molecules. So 1 mole of a substance has 6.02 times 10 to the 23 molecules. And that means if we want to get the number of moles, 1 mole has 6.02 times 10 to 23. The number of moles would be a number of molecules over 6.02 times 10 to the 23. So this is from Avogadro's law. The point of this questions would be to calculate number of moles. So we need to know, how do we calculate number of moles? Well, that depends on what we have. So for example, if he gives me a mass in grams, he says I have 5 grams, 10 grams, 25 grams, whatever, and he's asking what is the number of moles, then I use this equation. Number of moles is mass over molecular mass. Number of moles is mass, which has to be in grams, over molecular mass. And that means from this equation, can I get mass if I need to get it? Mass would be number of moles times mR, or molecular mass. But what if we don't have a mass in grams? What if he's talking about gases and he gives me a volume, and that has to be in decimeter cubed? Then I can get number of moles is volume over 24. Remember that the volume in any of these equations has to be in decimeter cubed. So if he gives it to me in centimeter cubed, I have to divide by 1,000. Okay, what if we're not talking about gases? What if we're talking about sodium hydroxide solution, hydrochloric acid solution? Then the number of moles in that case would be concentration times volume. And again, the volume has to be in decimeter cubed. And that means if I'm asked to get concentration, then the concentration of a solution is number of moles over volume. So please keep these equations in mind. We need to know these 3 equations. Number of moles is mass over molecular mass. Number of moles is volume over 24 only for gases. Number of moles is concentration times volume only for solution. So he's going to give me a certain question, and let's apply all of this. So for example, a simple question would be calculate the number of moles of sulfuric acid in 20.0 centimeter cubed of a 1 mole per decimeter cubed solution. So the first question you're going to ask yourself is, what does he give me? He gives me 20 centimeter cubed. Remember that anything in centimeter cubed is the volume. 1 mole per decimeter cubed. Anything in mole per decimeter cubed, that is concentration. So he's giving me volume and concentration, and he's asking me to get number of moles. So which of these equations do I use? You remember? We said if we have a solution, we have concentration and volume, then the number of moles is concentration times volume. Concentration is 1 mole per decimeter cube. Now we said the volume has to be in what? The volume has to be in decimeter cubed. So if he gives it to me in centimeter cubed, I have to divide by 1,000. So this number of moles is 0.02 mole. Another question says, what is the concentration in mole per decimeter cubed? So he's asking me for concentration of a solution containing 7.84 grams of phosphoric acid, which is H3PO4, in 400 centimeter cubed of solution. So he's asking for concentration, but he's giving me what? He's giving me mass, 7.84 grams, and volume 400 centimeter cube. So how am I going to get concentration? In order to get concentration, I need that last equation which says concentration is number of moles over volume, but that means I need to get number of moles. How do I get number of moles? You should realize that he gave me mass, so I'm going to use that very first equation. Number of moles is mass over molecular mass. So the mass is 7.84. The molecular mass is the addition of all the masses. So I have 3 hydrogens, each has a mass of 1. Plus I have 1 phosphorus with a mass of 31. All of this is from the periodic table. Plus oxygen, which is 16. I have 4 of them. So that comes out to be a certain number. And that gives me 0.08 moles. So that is the number of moles. I can then use it to get concentration. We said concentration is number of moles over volume. Again, please remember the volume, you cannot put it as it is. It's in centimeter cubed. So before you put it into the equation, you have to divide by 1,000, and that gives you the concentration. Okay, usually he will give you an equation and he will ask something about the equation. So for example, here we have the equation of the reaction of sodium carbonate with hydrochloric acid to give sodium chloride plus water plus carbon dioxide gas. Now, what is the volume of HCl needed to react with 5.3 grams of sodium carbonate if the concentration of HCl is this? Now you have to remember that a balanced equation gives you the ratio between the number of moles. So that equation on top tells me there is no number in front of sodium carbonate, so that is 1. So if I have 1 mole of sodium carbonate, it reacts with 2 moles of HCl to give 2 moles of sodium chloride, 1 mole of water, 1 mole of carbon dioxide. Now, what is he asking about? He's asking about the volume of HCl, but what does he give me? So you look at what he gives me. He gives me 5.3 grams of sodium carbonate. So in all of these equations, he will give me a certain information. So now he's giving me the mass of sodium carbonate. And then he's asking me about HCl. But from the mass of the sodium carbonate, I need to get number of moles. So which of these equations am I going to use to get number of moles of what he's telling me? So he's telling me 5.3 grams, that is mass. So I need to get number of moles of sodium carbonate using that very first equation, mass over molecular mass. 5.3 over the molecular mass of sodium carbonate. Again, I'll remind you that molecular mass sodium from the periodic table has a mass of 23. I have two of them, so 23 times 2, plus 1 carbon with a mass of 12, plus 3 oxygens with a mass of 16. So this should give me the molecular mass of sodium carbonate. I put 5.3 over that. That gives me 0.05 mole of sodium carbonate. So he gives me information about something. So here he gives me information about sodium carbonate. I get from that information the number of moles. Then what is he asking me about? He's asking me about hydrochloric acid. So I look at the equation. So the second step is I look at the equation. The equation says that 1 mole of sodium carbonate needs 2 moles of HCl. So if this is the number of moles of sodium carbonate, 0.05, what would be the number of moles of HCl? Well, the equation tells me that it should be twice of the sodium carbonate. So it is 2 times the 0.05. This gives me the number of moles of HCl. Then what is he asking about? He's asking about volume. So how do I get volume? And remember, this is volume of a solution. So the volume would be number of moles over concentration. I got the number of moles 0.1, and he gives me in the question that the concentration is 2. So that gives me a volume in decimeter cube. Now, if he wants it in centimeter cube, to change from decimeter cube to centimeter cube, you multiply by 1,000. So that means that the volume of HCl needed is 50 centimeter cube. Are we following? Let's try another question. Here he says, I have 9.8 grams of potassium chlorate, and he already gives me the formula of potassium chlorate because we did not talk about chlorate in this syllabus, was heated to give potassium chloride and oxygen. And first he wants me to write the balanced chemical equation. Okay, let's start. Potassium chlorate, he already gives me the formula. Now, how do I write the formula of potassium chloride? Potassium chloride, potassium valency 1, chlorine valency 1. So this is potassium chloride plus oxygen. I'm reminding you again that oxygen is diatomic. That means I write it O2. Then you have to balance. How do you balance? You increase the one that is less. So if we have 1 potassium before the arrow, 1 potassium after the arrow, 1 chlorine before the arrow, 1 chlorine after the arrow, but the oxygen is less after the arrow, so I need to increase it. If I put 3 here and 2 there, then they will be balanced, but that means I have ruined the potassium chloride, so that is the balanced equation. Then what is the question? Determine the mass of potassium chloride formed. Okay, how am I going to get that? I look at the information he gives me. He gives me 9.8 grams of potassium chlorate. And we said from the information he gives me, I need to get number of moles. Again, which equation should I use? The one that has mass. So number of moles is mass over molecular mass. That comes out to be 0.08 mole. So I got the number of moles of what he gave me information about. Now, what is he asking about? He's asking about potassium chloride. I look at the balanced equation. The balanced equation tells me 2 of potassium chlorate gives 2 of KCl. That means the number of moles of KCl is the same as the number of moles of potassium chlorate. So number of moles of KCl is the same as what I got. Then what does he want? He wants the mass. How do I get mass? From the equation, mass is number of moles times mR. So I put the number of moles times the mR of what I'm talking about, KCl. This gives me a certain mass of potassium chloride. The other part of the question says determine the volume of oxygen produced. So now we're looking at oxygen. We already talked about KClO3. So KClO3, I have the number of moles of the KClO3. Now I look at the equation and I find that 2 of KClO3 would give 3 of oxygen. So the 0.08 will give how much? That means that the number of oxygen is 0.08 times 3 over 2. This gives the number of moles of oxygen. What is he asking about? volume. How do I get volume? Remember, we're talking about volume of a gas. So I'm going to use volume is equal to number of moles times 24. And that gives me a volume in decimeter cube. Okay, another type of questions. He gives me a reaction and he says 25 centimeter cubed sample of 0.2 mole per decimeter cube potassium hydroxide was neutralized by 28.40 centimeter cubed of sulfuric acid. So he's giving me information of potassium hydroxide. He has 25 centimeter cubed, which is volume, 0.2 mole per decimeter cube, which is concentration. So I have concentration and I have volume, and this is a solution. So which equation should I use? Number of moles is concentration times volume. Remember, the volume has to be divided by 1,000. So this gives me number of moles of KOH. Good. Then he's asking about what? Number of moles of sulfuric acid. So I go back to the equation. What does the equation tell me? It says 2 moles of KOH react with 1 mole of sulfuric acid. That means the number of moles of sulfuric acid is actually half of what we got for potassium hydroxide. So that gives me number of moles of sulfuric acid. And he's asking about what? Concentration of sulfuric acid. So how do we get concentration of a solution? That's the last equation there. Concentration is number of moles over volume. We got the number of moles and he gave me the volume up there, 28.4 centimeter cubed. So I divided it by 1,000 before I put it into the equation. Getting better? Let's try another one. This is a reaction between ammonia and nitric acid to form ammonium nitrate, and he's saying 25 centimeter cubed of ammonia of concentration 0.3 mole per decimeter cubed. So he's giving me information about ammonia. Was reacted with nitric acid and 15 centimeter cubed of nitric acid was required. Calculate the concentration of nitric acid. Again, he gives me information about what? About ammonia. He gives me the volume, 25 centimeter cubed of ammonia, and concentration. So which equation should I use? These are solutions. Number of moles is concentration times volume. So the 0.3 times the volume divided by 1,000. That gives me number of moles of ammonia. Then he's asking about what? Nitric acid. I look at the equation. Can you see the equation? 1 mole of ammonia reacts with 1 mole of nitric acid, and that means number of moles of nitric acid is the same as ammonia. Then he's asking about calculate what? Calculate concentration. Concentration is number of moles over volume. Again, the volume, he said 15 centimeter cubed of nitric, so I divided by 1,000 before I put it in, and I get the concentration of acid. Okay? A similar question here says he finds that 5 centimeter cubed of 0.90 mole per decimeter cubed of potassium iodide solution reacts with 8 centimeter cubed of lead nitrate. Calculate the concentration of lead nitrate. Again, let's go through this very quickly. The first thing I need to do is get the number of moles of what he tells me about. So he's telling me about potassium iodide. Number of moles of potassium iodide is solution, concentration times volume. So the concentration times the volume divided by 1,000 gives me number of moles of potassium iodide. Then I look at the equation. That's step 2. Look at the equation. What does the equation tell you? That the number of moles of lead nitrate is half of the potassium iodide. That gives me the number of moles. Now he wants concentration. Concentration is number of moles over volume. Are we okay with all of this? And this gives me a concentration. Remember, the units for concentration is mole per decimeter cubed. Are we okay? Let's try one more. A chemist neutralizes 25 centimeter cubed of 0.5 mole per decimeter cubed HCl. Calculate the amount in moles of HCl. So what was the number of moles of HCl? Number of moles, what does he give me? He gives me volume and concentration. So number of moles is concentration times volume. And then he's saying calculate the mass of calcium hydroxide. So we got number of moles of HCl. I look at the equation. What does it tell me? That the number of moles of calcium hydroxide is actually half of the HCl. So I get number of moles of calcium hydroxide, and then I can get the mass. Mass is number of moles times mR. Is that okay? Another one, he says calculate the volume in decimeter cubed of carbon dioxide formed when 0.03 mole of anhydrous magnesium carbonate is completely decomposed. Again, he gives me here the number of moles of magnesium carbonate. So I really don't need to sit down and calculate number of moles. So I can look directly at the equation and you can see that the number of moles of magnesium carbonate is the same as the number of moles of CO2. So the number of moles of CO2 is 0.03. Now, what is he asking about? Volume of carbon dioxide. Okay, how do we get volume of a gas? Volume is number of moles times 24. This gives me the volume in decimeter cube. Okay, this is another kind of question, so please pay attention. Here he's saying 20 centimeter cubed of a hydrocarbon was burnt in 175 centimeter cubed of oxygen. Now, first of all, do you remember what we mean by hydrocarbon? Hydrocarbon is something that has carbon and hydrogen. So here we have carbon and hydrogen, but the problem is we don't know C what, H what. So we're trying to get what is X and what is Y. And he's saying, I started with 20 centimeter cubed of a hydrocarbon. So that is 20 centimeter cubed. When we do organic, you will remember that burning of any hydrocarbon in oxygen will give carbon dioxide plus water. So he has excess oxygen, so it gives carbon dioxide and water, and we're trying to get the balanced equation so that I can get X and Y. Okay, so he says 20 centimeter cubed of a hydrocarbon was burnt in 175 centimeter cubed of oxygen. This is excess. This is not the actual volume that reacts. Now, after cooling, the volume of the remaining gases was 125. Remember that the 125 is the total of what? Of the carbon dioxide that was formed plus anything remaining from the oxygen. Okay? He added aqueous sodium hydroxide to remove the carbon dioxide. You know that carbon dioxide is acidic, so it reacts with a base. And he found that after he removed the carbon dioxide, he was left with 25 centimeter cubed of unreacted oxygen. Remember, we had 125. He removed the CO2 and we're left with 25. That means the CO2 was how much? 100. And then 25 of the 175 remained. That means how much oxygen reacted? 150. So the volume of oxygen used was 150. The volume of carbon dioxide formed was 100. Now he's saying deduce the formula. Remember that we said Avogadro's law says 1 mole of any gas occupies the same volume. So 1 mole of, we can relate directly in the equation using number of moles or using volumes of gases. Remember, we can relate directly in the equation number of moles or volumes of gases. In all the previous questions, we were relating number of moles. Here we have all gases, so we're going to relate the volumes. I don't need to calculate number of moles. So if 20 centimeter cubed of the hydrocarbon reacts with 150 of the oxygen to give 100 of the CO2, I can simplify these ratios. Dividing by 20, I will get 1 of CXHY plus 7.5 of the O2 to give 5 of CO2. Remember the 20, 150, 100, I divided all through by 20 to simplify the ratios. So this gives me the ratio of the number of moles. So this gives 1 to 7.5 to 5. Now, Looking at that, that means that X is 5. And then if I balance all of this, I will need to put 5 in front of the water, and that means my H is 10. So this is the balanced equation, and that means my hydrocarbon is C5H10. Please pay attention to this. Okay, this kind of question comes a lot in several papers. Okay, another type of question says basic lead 2 carbonate has a formula X PbCO3 Y PbOH twice, where X and Y are whole numbers, and we're trying to determine what is X and what is Y. And he's telling me that the lead carbonate alone, of course, he's heating all of this, the basic lead 2 carbonate, which is X with Y. But the lead carbonate alone will give carbon dioxide gas. The lead hydroxide alone gives the water. Now, he's giving me information when heated, the basic lead 2 carbonate gave 2.112 gram of carbon dioxide and 0.432 grams of water. So first of all, he wants you to get the number of moles of each. Of course, number of moles is mass over molecular mass. So for the CO2 is the mass of the CO2 over the mass of 1 mole. Remember that the word mass of 1 mole means molecular mass, means instead of sitting down to calculate carbon is 12 plus oxygen is 16 times 2, he already calculated it for me. So mass of 1 mole of something is the molecular mass. So we get number of moles of CO2. Also, we have a certain mass of water. So again, we're going to use the same equation, mass over molecular mass. So now I have values for number of moles. Remember, to get X and Y, I need to simplify these. So if I divide through by the smallest, this gives me a ratio of 2 to 1. And that means that the formula up there is actually 2 of lead carbonate, 1 which is not written of lead hydroxide. Are we following? Okay. Now, another thing that you will be required to calculate is percent purity. And you have to keep in mind that the percent purity is the mass of the pure substance over the mass of the impure times 100. Now, what does this mean? Let's take a look at this question. He's telling me an excess of hydrochloric acid was added to 1.23 grams of impure barium carbonate. Now, if he's giving me mass of impure something, that means you're not going to use that mass for anything. You're not going to use that mass to calculate number of moles, because actually it is not the actual mass of barium carbonate, it's the mass of barium carbonate plus impurities. So don't use the 1.23 grams when he says it is impure something. Don't use it to get number of moles. We're going to use the other information that he gives me. Okay, what is he talking about? He says the volume of carbon dioxide collected at, and this is room temperature and pressure. RTP is room temperature and pressure, was 0.12 decimeter cube. So he's giving me the volume of carbon dioxide. And he's saying calculate the percent purity. From the volume of the carbon dioxide, I will get number of moles. So if he gives me volume of a gas, how do we get number of moles? Number of moles is volume over 24. And then I look at the equation, and I find that the equation says 1 mole of CO2 is equal to 1 mole of barium carbonate. The number of moles are the same. So the number of moles of barium carbonate is the same as that of carbon dioxide. So that comes out to be the same number. Then we use the number of moles of barium carbonate to get mass. How do I get mass? Mass is number of moles times mR. So this 0.985 is the actual mass of barium carbonate that we have. But if he wants the percent purity, we said that is the mass of the pure, 0.985, over the mass of the impure, 1.23, times 100. And that means that my barium carbonate sample was only 80.1% pure. To calculate percent yield, you should know that percent yield is actual yield over theoretical yield times 100. What does that mean? Let's try a question. He's telling me 4.8 grams of hydrogen reacted with nitrogen to give 12.8 grams of ammonia. Calculate the percent yield. Now, percent yield, that means I'm not going to use the 12.8 now for anything. He's telling me information about 4.8 grams of hydrogen. I will use that to get number of moles of hydrogen. So that is mass over molecular mass. Remember, we're talking about hydrogen, that is H2. I'm reminding you that to get the molecular mass of something, you do not include the balancing. So when we say MR of hydrogen, it's H2. H2 has an MR of 2. You don't use that 3 in the balancing for anything to get number of moles now. So he's saying number of moles of hydrogen, mass over molecular mass, 4.8 over the 2, that is 2.4 moles. And then I look at the equation and decide what would be the number of moles of ammonia. Well, the equation says 3 moles of hydrogen give 2 moles of ammonia. So the number of moles of ammonia is the 2.4 times 2 over 3. That gives me number of moles of ammonia. Now I need to calculate what is the theoretical mass of ammonia. So from your calculation, you get that you're supposed to get 27.2 grams of ammonia. But what did he actually get? He got 12.8, and that means his percent yield is what he got, 12.8, over what he should get. He should get 27.2 times 100. That gives you your percent yield. So let's take a look at this question. He's saying hydrobromic acid reacts with magnesium carbonate to form a solution containing magnesium bromide. Crystals of hydrated magnesium bromide can be obtained from this solution. And the question is, an excess of hydrobromic acid is reacted with 0.125 mole of magnesium carbonate. So he already gives me the number of moles. I don't need to sit down and calculate number of moles of magnesium carbonate. Now show by calculation that the maximum theoretical mass of hydrated can be made is 36.5. Yani he's saying calculate the mass that you should get. Okay. So he says I have 0.125 mole of magnesium carbonate. So I look at that equation on top to get the number of moles of the hydrated magnesium bromide. That would be the same as the number of moles of magnesium carbonate. Looking at the equation on top, you can see that number of moles of magnesium carbonate is the same as magnesium bromide. Then he says the mass should be what? The mass is the number of moles times MR. So the 0.125 times the MR of the hydrated magnesium bromide, which he gives me there. So this is the mass. Then he says in an experiment using 0.125 mole of magnesium carbonate, so that is the same number of moles from that first question, with an excess of hydrobromic acid, the mass of hydrated magnesium bromide obtained is 26.4. We just calculated that he was supposed to get 36.5 grams. But actually, when we do any experiment in the lab, what we get is usually less than the theoretical yield or what we should get. So in this experiment, we should get 36.5 grams. But when he did it, the mass obtained is 26.4. So just 2 reasons why the actual mass obtained is less than the theoretical mass. We said always when we do an experiment in the lab, so if I'm trying to prepare these crystals in the lab, I'm supposed to get 36.5, but I will always get less. So here, for example, he got only 26. Now, why do you think we get less than what we should get? Probably what we start with is some of it did not react, so some magnesium carbonate did not react, or that the magnesium carbonate we started with was impure. These are 2 of the reasons why what we actually get in the lab is usually less than what we should get. Okay, this question says copper carbonate is broken down by heating to form copper oxide and carbon dioxide. And he gives me the equation. And he says 31 grams of copper carbonate are heated until all the contents of the test tube have turned from green to black. Of course, you should know that copper carbonate is green, copper oxide is black. And he says the yield of copper oxide is 17.5. That means that when he did the experiment in the lab, what he got was 17.5 grams. And he's asking me what is the percentage yield. In order to get the percentage yield, I have to calculate how much he should have got. So what is the theoretical mass that he should have got? Okay, he gives me information about 31 grams of copper carbonate. I get the number of moles of copper carbonate. Copper, number of moles is mass over molecular mass. This is the molecular mass of copper carbonate. So the number of moles comes out to be 0.25 moles. And then we want to know copper oxide. We look at the equation and we find from the equation the number of moles of copper carbonate is the same as number of moles of copper oxide. So the 0.25 mole is number of moles of copper oxide. And from that I can get mass. Mass is number of moles times mR. And we calculate that we are supposed to get 20 grams. Now, what did he actually get? He got 17.5. Remember, the word yield means the mass that was obtained. So that means we said, how do we get percent yield? It is what he actually got, 17.5, over the theoretical that we calculated. So over what he should get, which is 20 times 100, that gives me a percent yield. Okay, so from these choices, my answer is D. Another kind of question. He has equations of strontium chloride made from strontium carbonate. And he says, in the above experiment, 50 centimeter cubed of hydrochloric acid of concentration 2 mole per decimeter cubed was used. 6.4 grams of strontium chloride was made. So this is what he actually got. Calculate the percentage yield. Again, he started with 50 centimeter cubed of HCl concentration 2 mole per decimeter cubed. So I can use that to get number of moles. Number of moles is concentration times volume. Again, don't forget to divide the volume by 1,000. So that gives me the number of moles of HCl is 0.1 mole. Then he's asking about strontium chloride. I look at the equation on top. What is the relationship between number of moles of HCl and number of moles of strontium chloride? The equation says 2 of HCl gives 1 of strontium chloride, and that means number of moles of strontium chloride is half of what we have for HCl. Now, then he says mass of 1 mole. Again, I'm going to remind you that mass of 1 mole is the same as molecular mass. So he already calculated masses of strontium plus chlorine plus hydrogen and so on to get 267 grams. So you don't need to sit down and calculate molecular mass. And he's asking for theoretical yield. Again, I'm going to remind you the word yield means mass. So he's asking for the mass. I already have number of moles. So the mass is number of moles times the MR that he already gives me. So that means I'm supposed to get 13.35 grams. But what did he actually get? If you look on top, he got only 6.4 grams. So his percent yield is the 6.4 over what we calculated, which is the theoretical yield, times 100, and that gives me the percent yield. Okay? Limiting reactants. We use limiting reactants when he gives me information about both reactants. So if he's giving me information, for example, I have nitrogen plus hydrogen to give ammonia. In all the previous questions, we had information about only one of the reactants, and we use that to get anything he's asking about. But here, if he gives me information about both reactants, I have to decide which one is excess and which one is limiting. So the limiting reactant is the one that is not excess. So if he gives me information, 50 grams of nitrogen and 40 grams of hydrogen, I calculate number of moles of nitrogen, mass over molecular mass, and number of moles of hydrogen, mass over molecular mass, and I get the number of moles of each. Then I look at the equation and decide which one is excess and which one is limiting. So looking at the equation, we can see that 1 mole of nitrogen needs to react with 3 moles of hydrogen. And that means that the number of moles of hydrogen should be 3 times that of nitrogen. So how much nitrogen do we have? We have 1.79 mole, let's say around 2 moles. What would be the number of moles of hydrogen? It should be 6 moles or less than 6 moles. How much did he actually put? He actually put 20 moles. That is way too much, more than needed. So we say that the hydrogen is excess. It is more than needed. We need only about 6 moles and he put 20. So the hydrogen is excess, and that means the nitrogen is limited. And when he asks about anything else, we use the information about nitrogen, not the information about hydrogen. So I'm not going to use number of moles of hydrogen for any further calculations. I look at the number of moles of nitrogen. So he wants ammonia. Ammonia is twice that of nitrogen. Can you see that from the equation? 1 mole of nitrogen would give 2 moles of ammonia. So the number of moles of ammonia is twice what we have for nitrogen, and that means I can get the mass of ammonia, number of moles times mR. Another example, here he says 0.096 grams of magnesium was added to 25 centimeter cubed of 0.4 mole per decimeter cubed hydrochloric acid. Again, here he's giving me information about both reactants. So I need first to decide which one is excess. So number of moles of magnesium, what do we have? 0.096. So I'm going to say mass over molecular mass. That gives me a certain number of moles of magnesium. Now we want number of moles of HCl. What do we have? Concentration times volume. That gives me number of moles of HCl. And then I look at the equation. In order to determine which one is excess, I look at the equation. The equation says that the number of moles of hydrochloric acid should be twice magnesium. So if I have 0.004 mole of magnesium, how much of HCl do I need? I need twice of that. That's 0.008. That is less than what he put. He put more than what we need, so the HCl is excess. Are we following all of this? Okay. Again, calculate the mass of carbon dioxide given off when 20 grams of calcium carbonate react with 40 centimeter cubed of hydrochloric acid of concentration this. So he's giving me information about the calcium carbonate and the information about the hydrochloric acid, and he wants mass of carbon dioxide. So I need first to decide which one is excess. So number of moles of calcium carbonate is the mass over the molecular mass. What about the HCl? What does he tell me about the HCl? Number of moles is the concentration, which is 2 mole per decimeter cube, times the volume divided by 1,000, of course. So I get number of moles of HCl. Then I look at the equation. What does the equation tell me? It says that if the number of moles of calcium carbonate is 1, the number of moles of HCl should be 2. That means number of moles of HCl should be twice calcium carbonate. Okay, so number of moles of calcium carbonate is 0.2. Twice of that is 0.4, but I have much less added of the HCl, so my HCl is limiting, or my calcium carbonate is the excess. Because if I have 0.08 of HCl, I will need only half of that from calcium carbonate. So I need 0.04 mole. He put 0.2. That's way too much. So my calcium carbonate is excess, or my HCl is limiting. Now he's asking about what? Mass of carbon dioxide? Well, I'm going to relate it to the HCl. So looking at the equation, the number of moles of carbon dioxide should be half of the HCl. So that is 0.04. And from that, I can get the mass, number of moles times mR. Another type of question, he says 20 centimeter cubed of sulfuric acid with this concentration was added to 40 centimeter cubed of sodium hydroxide with this concentration. So how many moles of sulfuric acid were added? Again, concentration times volume. How many moles of sodium hydroxide were added? Concentration times volume. And then I look at the equation. Well, the sulfuric acid should be half of the sodium hydroxide. Is the sulfuric acid half of the sodium hydroxide? The sodium hydroxide is 8 times 10 to the minus 3, so half of it should be 4 times 10 to the minus 3. So obviously the acid is excess. I need only 0.004 mole, which is less than the 6 times 10 to the minus 3 that he added. Then he has a question. So we've decided that it is the acid that is excess in the solution. Then he's saying, is the pH of the final mixture less than 7, equal to 7, or more than 7? How do we know? Well, we just said that the acid is excess. That means I have a lot of sulfuric acid in the solution. What is the pH of acid? Less than 7. And that's the end of this part. I hope this has clarified a lot about this chapter. Please practice all these questions again, and thank you for listening.